Hey guys, welcome back. Today we are going to be doing composition of functions, which means for today we will add, subtract, multiply, and divide functions, and we will find the value of a function of a function. So when we add, a slightly less formal version of this right here that you may have seen before would be f of x plus g of x, which just means x squared plus 3x minus 10 plus x plus 5. So we're going to combine like terms. There's an x squared. There's no x squared over here, so x squared. 3x plus x is 4x, and negative 10 plus 5 is negative 5. Now those parentheses really didn't do anything for us in this particular problem, but it's good to get in the habit of just having them because there are some times when they actually will make a difference. So get in the habit of keeping those parentheses. So g of x minus f of x. This is one where the parentheses definitely will matter. So we want the parentheses to make sure that we remember to apply that negative to every term here in f of x. So we have no x squared here, minus x squared. Then x minus 3x is negative 2x. And 5 minus negative 10 is 15. Then f of x times g of x. So x squared plus 3x minus 10 times x plus 5. So here we need to distribute. When I distribute the x squared, we get x cubed plus 5x squared. Then I'll distribute the 3x, and I'll get 3x squared plus 15x. And then distribute the negative 10. Minus 10x minus 50. And then combine like terms. X cubed is all by itself. Then I've got 5x squared and 3x squared, so that's 8x squared. 15x minus 10x is 5x, and then minus 50. f of x divided by g of x. X squared plus 3x minus 10 divided by x plus 5. A lot of times the first thing we want to do is try to cancel out an x, maybe in a couple of these terms, or cancel out the 5 with that 10. But we're looking at 5 different terms, and if I can't cancel something out of all 5 terms, then I can't cancel it. What I can do is simplify or factor. I can factor that denominator, and a number that multiplies to 10, or two numbers that multiply to negative 10 and add to positive 3 are 5 and negative 2. So this will factor to x plus 5 times x minus 2 over x plus 5. In this step up here, I was looking at 5 different terms. Now down here, I'm not looking at terms anymore. I'm looking at 3 different factors. Factor here, here, and here. And I can cancel factors. So I'm left with x minus 2. So k of x plus m of x. I'm just looking to combine like terms. I've got 2x squared, and then 2x minus 4x. A of x minus m of x, and here again is where these parentheses are really going to matter. Okay, so no x squared here minus 2x squared. And then 2x minus negative 4x is positive 6x. K of x times m of x. So that's 2x times 2x squared minus 4x. Another time when the parentheses are going to matter. And here we distribute. So I get 4x cubed minus 8x squared. K of x divided by m of x. Two things I could do. I could factor the denominator and cancel out factors, or I've got three terms and all of them have a 2 and an x that will go into them. So if I divide everything by 2x, I'm going to get 1 over x minus 2. And certainly to have a decent denominator here, I can't have a 0 denominator, so x cannot equal 2. Now we're going to do a function of a function. So another way of writing this would be f of g of x, which means g of x gets substituted in all the x's in f of x. So that's x plus 5 squared. That x is gone. X plus 5 goes in its place. The next x goes away. X plus 5 substitutes in for it. So x plus 5 squared means x plus 5 times x plus 5. And that gives us the first term squared plus double the product. The product is 5x, double that is 10x, plus the second term squared. Then I can distribute and combine like terms. Got a 10x and a 3x, and then 25, 15, and negative 10 makes 30. Number 10 is backwards. Here, f of x gets substituted in to g of x. So g of f of x is this x gets replaced with all of this. X squared plus 3x minus 10 plus 5. And here are my like terms. X squared plus 3x minus 5. So in number 11, a of m of x means m of x is getting substituted into k of x. So it's 2 times, and the x becomes 2x squared minus 4x. And I distribute. 4x squared minus 8x. And last, m of k of x. That means that k of x is substituted in to m of x. So that's 2, and then the x becomes 2x squared minus 4, and that x becomes 2x. So 2x to the second power is 4x squared. I can multiply these and get 8x. And then 2 times 4x squared is 8x squared.
Before we leave this lesson, I think it's important that we get a little bit more practice on domain. Domain is something that people tend to struggle on a little bit, so the more practice we can get, the better. So when we do domain, there's two things that we're looking for. One is a variable in a denominator. The second thing we're looking for is a variable under a radical. Here we have a variable in a denominator. When there's a variable in a denominator, we need to find out what value for that variable would give us a denominator of 0 where the fraction is undefined. So we're going to say 5x times 3x minus 2, that denominator, cannot equal 0. So this looks like kind of like a factored form to me. So I could say this factor can't equal 0 and this factor can't equal 0. So 5x cannot equal 0 and 3x minus 2 cannot equal 0. So I'll divide both sides by 5. X cannot equal 0. Here I'll move that 2 over. 3x cannot equal 2. And divide. X cannot equal 2/3. Okay? So from there, we can write our domain. So the domain is all real numbers, so it's the set of all x, such that x cannot equal 0 or 2/3. In number 2, I have a denominator with a variable, so I can say that denominator cannot equal 0. I also have a variable underneath a radical, so I can say that what's under that radical, x squared minus 11, cannot be negative, so it has to be greater than or equal to 0. So here, I'm going to square both sides. So x squared minus 11 cannot equal 0 squared, which is 0. I'll move this over. X squared cannot equal 11. And then I'll take a square root. X cannot equal plus or minus the square root of 11. Here, I'll move this over. X squared is greater than or equal to 11. Okay, now when I take a square root, this is going to split up into two separate inequalities. X is greater than or equal to the square root of 11. X is less than or equal to the opposite of the square root of 11. Except here it says it cannot equal either of those. So I actually am not going to be able to keep that or equal to. Okay, so the domain is that x's are greater than the square root of 11 and x's that are less than the opposite of the square root of 11.